In this video, I'm going to talk about the NPN and the PNP transistor and how these transistors are constructed on an integrated circuit. So recall that the symbol for the NPN transistor, where this is the base, this is the emitter terminal, and this is the collector terminal. And I'm going to use a color code. Green color is going to denote N-type silicon, and yellow color is going to denote P-type silicon. So let's start with a silicon wafer. And let's draw the surface of the silicon wafer. And the thickness of the wafer is in this direction. And this is a P-type starting material. And the first step I'm going to do is I'm going to diffuse into this P-type an N-type region. I'll show here in green. Now this is a very concentrated N-type material that's called the buried layer. BL for buried layer. The next thing that is typically done is that a layer of silicon, of N-type silicon, is grown on top of this wafer. So I'll draw that here. And so this region of N-type material is called an epitaxial layer, and it's rather lightly doped. The buried layer is highly doped, but the region grown on top is lightly doped. And with further processing steps, this buried layer will tend to diffuse up a little bit into this N region. So let me erase this part. So the next step is we're going to diffuse in a P-type material. And so we'll diffuse in a P-type material here. And at the same time, a P-type material will be diffused into this region. What this does is it forms an N-type tub. This region of N-epi is isolated from this other N-epi. The next thing I want to do is do a P diffusion for the base region of the NPN transistor. So I'm going to diffuse in a base region, and at the same time I'm going to put some of this base region into this deep isolation diffusion. So I'll put a little base region into here. Now the next step, I'm going to take in some N material and I'm going to dope this region with an N material. And at the same time, I'm going to put a higher concentration N material over here. So this N material here is going to form the emitter terminal of my NPN transistor. This base region will be connected to metallization. I'll label it B for base. This region will connect to metallization at the surface of the wafer. This region is the collector region. So you can see that here we have an N region, we have a P region, and another N region. So you can see we have an N, P, N. Let me erase that for now. One thing to notice is that underneath the emitter, the base region is very thin. And that is so that the electrons that get emitted into this base will diffuse over into this collector region. And will go out the collector terminal. So we always think in terms of positive current. So the positive current will go in the opposite direction of the electrons. So the positive current will go from collector to emitter. And there will be some base current that will flow in this base terminal, which will be in this direction. So let me erase some of this again. So let's shade in these different regions to make it a little more clear. The N region is lightly doped N region here, and underneath this base region, this is lightly doped. This is lightly doped N region. And over here, the other side of the isolation, we have more lightly doped N region. This is lightly doped N region over here at the left. And this buried layer is very heavily doped for low resistance. This emitter region is very heavily doped here. And this contact is heavily doped, so that we get a good contact when we connect metal to this doped region. Now the P-type material is this region in here, this part that isolates the different tubs of N material. So we have an isolation P-type region here. The wafer is P-type material, so this is all P-type material. So one thing to observe is that we have a PN diode. For example, here we have a diode. I'll draw the diode symbol. So we have a P material, we have an N material. Now this isolation region over here also forms a diode. So we have a diode, P material, N material. This buried layer, it forms a diode. So the collector region, which is this region of the buried layer, there's a parasitic diode, and I'm going to draw that on the transistor symbol. So we have this diode. And this, the wafer starting material, will be at the ground potential. So as long as the anode of this diode is at ground potential, it won't come into play and it can be ignored. So let me, so the document's a little less cluttered. I'm going to erase our diode here. And let me highlight the base region. This is P-type material under the emitter here. So you can see what happens. Let me change the brush here. Let me change the color. This region is an isolation region. I'll call it ISO. And what that does is it isolates these tubs. This is the tub region. And that's where our NPN transistor is constructed. Now, there will be another tub region over here. And perhaps resistors will be in this tub region. And over on the other side of this isolation, there's another tub over here that extends to the right. And for example, there could be perhaps a PNP transistor in that tub. So this isolation region allows us to create different devices and have those devices isolated from each other. So now let's look at how a PNP transistor will be constructed. I will scroll down here. The PNP transistor will be constructed using exactly the same layers as the NPN transistor, but combined in a little different way. So let's again draw the surface of our silicon wafer. And the thickness of the wafer extends in this direction. Now, just as we did with the NPN, we're going to diffuse in an N material buried layer. And we're going to grow an epitaxial N region, same as we did for the NPN. Again, the buried layer will diffuse up a little bit into this, what we call epi or epitaxial layer. And let me again erase this. Again, we're going to diffuse in a p-type material. We'll go all the way down through the epi region, and at the same time put in another isolation region here. So now we're going to build the PNP in this isolated tub. So now we're going to diffuse in some P material. I'm going to diffuse in some P material here, here, and here. So when I made the NPN transistor, I had one big base region, but now I have three different regions. This region will be the emitter of the PNP. I'll label E. And this P region here will be the collector. This P region will be the collector. So these collector regions here and here form a ring around the emitter. So if I draw the third dimension, the emitter would perhaps go like this. This collector region would surround the emitter. Now I want to put in another diffusion layer, which is an N-type material. It's the same layer used for the emitter of the NPN transistor. It's a highly doped N material. This is a highly doped N material in the buried layer. This is a lightly doped N material, I'll call it N minus. And so what we have here is P material here, we have an N material here, and we have a P material for the collector. Thus we have a P and P. Now let me erase some of this for clarity. So let me shade some of these regions so it's a little clearer what's what. So this region here is a P material, and I forgot to, let me change pins here. When this P region is put in, I'm going to put a little P region into this isolation area that I forgot to do that. So let's add that in. That gives me a little better contact to this isolation region. So let's go back to shading in our different regions. This is P region. The starting wafer is P material. This is all P material. This collector region is put in at the same time as this emitter region, as this collector region. So what happens is that this emitter base junction, well, let me finish shading this first. This is highly doped N region. This is highly doped N region. This is lightly doped N tub here. And the next tub at the right is over here. Next tub at the left is over here. So when this emitter base junction becomes forward biased, we emit holes into this region. And most of these holes will diffuse over and get collected. Actually, there's a built-in electric field at the upper edge of this buried layer. And I'll draw that here, pointing upwards. And what that built-in electric field does is it tends to prevent the holes from encountering this buried layer region. So the holes are kind of pushed up at the surface. And this PNP is called a lateral PNP because the holes go horizontally to the collector. In the NPN transistor, it was a vertical transistor because the carriers from the emitter went down to the base and down more to the collector. Let me just add here that this is the base terminal of our lateral PNP. So the base terminal of the lateral PNP, this base region is here, actually corresponds to the collector region in the NPN transistor. So the layers are the same, but the function of the layers are a little different. So hopefully this gives you an overview of how the PNP transistor and the NPN transistor